Any sufficiently advanced technology is indistinguishable from magic.
I was 11, 12 years old. My dad came home with a computer. It's an MSX machine.
TRS-80.
Commodore 64.
I was really young.
It didn't have a hard drive.
And then it kind of accelerated from there.
If you have to worry about nothing else than what you're actually focusing on, what you're actually passionate about, then there is no way you are not going to succeed.
There's a moment where an experience becomes so intuitive that you don't even think about, the underlying complexities.
What developers can look forward to is the unlimited possibilities that they can create in their own minds.
But to create, you need tools.
We provide you with the tools to do it, and then we kind of step back and just allow you to be the one who's holding the brush or creating the thing that you're envisioning.
I don't think it's in our nature as human beings to just accept things as being good enough.
We're designing an engine to be used by any type of artist with any goal in mind.
The easier we make it for them to express themselves, the more we'll see people who attempt.
We're really at the infancy of what Unity can bring to the world.
I could use it for training pilots.
My son is 11 years old. He's using Unity.
Recreate brain images before they go in and do brain surgery on patients.
We're good for anybody that wants to create.
Gaming is in our DNA. We'll never leave gaming behind.
We'll always be there for you.
I would love to tell everybody who uses Unity, thank you.
Thank you.
Thank you.
Thank you.
Thank you so much.
Thank you.
It's all about the users.
We can hear them like we can hear our family.
Good morning and welcome to Unite Singapore 2018. Today, all of you, as our family of users, will get to hear firsthand about how Unity technologies allows for limitless creations, games, animations, and applications that you're all so passionate about. Powering the Unity toolset are, of course, the people who work here at Unity, the software developers, QA engineers, and product teams who produce world-class qualities and features for the Unity engine. Business development, marketing, and technical folks who are constantly at the front line, helping users like you better understand Unity's core and monetization products. The behind-the-scenes people from customer support, finance, legal, sales operations, recruiting, and workplace experience teams who keep Unity a well-oiled engine. I'm very happy to announce today that Unity Technology Singapore, home to our APAC hub and global 2D development team, is selected to be one of the winners of the Tripartite Alliance Award 2018, recognizing us as one of the best workplaces here in Singapore. It gives me great honor to welcome on stage Ms. Julia Ng, Deputy General Manager from the Tripartite Alliance for Fair and Progressive Employment Practices, also known as TAFEP, to present the Tripartite Alliance Award to our President for APAC, Mr. Hubert Rinaldi. Julian Hubert, please. Thank you. Yeah. Thank you.
Thank you. Good morning, everyone. I'm really happy to see everyone here so bright and early to join us to be at Unite Singapore. Today, I have some really exciting news to share with you. Unity has won an Emmy for technology and engineering, and this was made possible through a collaboration between Disney and Unity for Baymax streams. This week is a great week for announcements. We also were at Autodesk University sharing that Unity is bringing together our real-time 3D platform with tools such as Revit, VRAD, and Shotgun. What this means is better workflow for folks in these industries. And before we step into our conference proper, you saw our video, we want to thank you, our creators and our audience, and I want to take a minute here to share about you. We are very lucky today to have representatives from 33 nations in the audience with us. The youngest member here is 15 years old. And we hope that in today's session, that lineup we have planned for you will be inspiring and keep you interested for even Unite 2019. Now, in Unity, we value you, our users. It's in our DNA, it's in our value system. It comes right from the top. John Ricciardo, our CEO, made this statement. The world is better place with more creators in it. And we support you, our community of creators, through our basic principles. Unity's principles are democratized development. What this means is if you want to be a creator today, you can go online, download our software. We provide the same tool sets if you are an indie developer or a AAA studio. Second principle that we follow is to solve hard problems. I'm not sure if you guys have ever experienced operating system changes and having to maintain code for that, or if you wanted to actually put your creation on more than one platform, that means separate code base to maintain. Unity takes care of that. That's what we mean by solving hard problems for you. And the last part is when you're ready to publish your great creation, we have a great monetization platform with a team behind it, ready to support you to enable your success. In the real-time 3D development space, Unity is very lucky to have all of you creators supporting us and choosing to use Unity. For many years, Unity has been known as a game engine. Today, we are a creators engine, but that means we're just making more tools available for more creators out there, but we're not forgetting the game developers, but we're just allowing and welcoming more creators in the other verticals such as automotive, architecture, engineering, construction, as well as film animation, to be in this space with you. In today's keynote agenda, our team will be coming up to share with you more details about things like our latest statistics and data, who will be helmed by Xing Yu, our lead business development for Malaysia, Singapore, and Indonesia. We also have invited evangelists from Australia. John Sitzmer will be sharing with you an update on the FPS sample game. And further afield, we welcome Josh Naylor from Yorkshire, who will take us through visual effects graph. And our own Russ Scammell will be sharing with us insights into the new features for 2D development. And finally, reserve some of your welcome for our lead field engineer, Yifei, who will be sharing with you all the updates from 2018. So before we start the program with our speakers, do give us 5 minutes to share with you some of the latest creations from our indie developers. Thank you.
Hello everyone, welcome again to Unite Singapore 2018. Don't you think that 3 billion is a huge number? It's the number of devices which has Unity experiences installed. 28 billion installations, or 53 installations per second. So, as I shared this piece of information, in 10 seconds, 530,000 installations have occurred. That impressive number is only possible with our amazing Unity developer community, meaning every one of you in the audience. It is clearly possible to create a top game in Unity, as proven by the 40% among the top 1,000 games in the marketplace today. With the number of new games made by Unity developers, you know that you are part of a community who can support and share their knowledge and journey with you. When VR/AR appeared, Unity saw the opportunity and challenge for our developer community who might be interested in these platforms. Unity solved this hard problem by making it possible to deploy directly to most VR/AR devices. Today, we see 60% of all VR/AR content have taken advantage of this easier deployment process. We are seeing more film and animation studios looking at creating their projects in Unity. International events such as Tribeca Film Festivals, Tribeca Immersive, or Sundance Film Festival's New Frontier Showcases have seen more than 50% of content made in Unity. Fast Company, a publication focusing on technology, business, and design, listed a number of companies which are innovative in AR and VR. 90% of these are powered by Unity. Now, closer to home, our evangelist for Australia, John, was at the Melbourne Film Festival 2018, and he shared with me that he saw a number of animation projects powered by Unity at the event. One of the best things about Unity is the ability for developers to create a project and deploy it to multiple platforms. For mobile, that means iOS, Android, and Windows. Besides mobile, we also look at console, VR/AR platforms, which make up over 25 platforms, and the most recent addition to this list being Magic Leap. Only 3 countries in the world do not have Unity developers working on projects. In Unity, we believe that it is never too early nor too late to learn how to develop on our engine, so everyone can be a student. And today, we have 1.4 million students learning Unity, and we would love to grow this number together with you. Please allow me to share with you a short video of a few projects made with Unity.
So when you're learning Unity for the first time, you're using demos and tutorials and things from the asset store. You're using those building blocks to learn. But I find that often people get to a certain point in their career where they're going, how do I get the skills to develop a full commercial grade engine? The tutorials aren't helping anymore. One thing that's really useful in this case is to have a large sample game. A large game you can pull apart, pull the levers, poke at and see how it works to get the best practices and tips and techniques. So we've created the FPS sample game. This is something you can run in the editor and learn not only what you can make, but how you can make it. So let's look at some gameplay. That's pretty awesome, right? This is a great game. So if you're like me, when you look at that, you're saying, how do I make that? How do I develop the skills to make something like that? How do I, for example, get the hands to hold the weapon correctly? If I'm switching out weapons, how do I get the hands to go in the right spot? Well, now you have the complete project. You have all the source code. So you can have a look at the IK script here to figure out how that's done. And if you're an artist, you might look at this flower here and go, how do I get the red flower to behave like that? Is it self-illuminating? Is there subsurface scattering? What are the techniques that are used? So go inside the project, find that material, and figure out how it's all made, how it's put together. Every single frame has lots and lots of questions. How is the character controlled? Has audio done? What's the animation system that's used? How is UI put together? So you can dig in, and obviously I can't cover all that today. So today I'm just going to pull out two things to talk about really quickly, and that is the netcode and HDRP. So if you're thinking about netcode, how would we make a multiplayer game? Some of the things you're going to be thinking about are having an authoritative server to stop people cheating, having client-side prediction and lag compensation so you can have smooth gameplay. But your boss might be thinking about the costs. How do I use network compression to reduce memory bandwidth? And how do I have a small memory footprint so I don't have to spin up lots of servers when I get new players? So this uses our new network transport layer. It's in preview now. But the part of the job of the FBS sample team is to try out these new features, find the bugs, find the best practices, and basically we're going to break things so that you don't have to. Let's look at the HDRP. So this is a completely new rendering pipeline, and it can be tricky to go, how do I use a new rendering pipeline to achieve my artistic vision? So you can take this project, pull all the levers, change the sliders, move things around to figure out how you can make your own artistic expression here as well. You can look at the HDR lights, post-processing effect, how to look at our materials, how to put all this together. So what we're really doing here with this project is we're creating a manual without words. What that means is, this is the sort of stuff that doesn't go in tutorials, doesn't go in demos. It's not only about the big features, but it's also about all the little details that go into a project like this that get recreated every time someone makes a game. And usually people keep reinventing this sort of stuff. And so we're going to give you these techniques here so you can learn from them. Let's switch over now to the game. I've got Ife here helping me, and he's going to, so we've got the project open here, and there's a couple of things I want to point out. One is we have, so here we are running around, here's the game in action. It looks beautiful. And in the editor, what we have is we have a series of tools that help with workflow. This is really important when you're working on a larger game and to make your team effective. On the right here, we can see that we have project tools for building assets, building a game, opening levels, and for launching the game. If you're working on a multiplayer game, one of the key sticking points in your process is the ability to quickly launch servers and clients to test your game. So we just have a start button here, and it's going to launch those for us. So going into the game now, it's not just in the editor we need to be productive, but in the game as well. So this game has a debug console, a Quake-style game debug console. I can do things like switch to the next character, and also show some profiling statistics. When your artists and level designers are in the project, you want them to be able to quickly and easily get information that's going to show them various hotspots or performance bottlenecks. So here we can see graphs and numbers to see how we're performing. And so going back to the editor now, let's have a look at the materials here. So if I was an artist and I'm working on these pipes and I want to change the color of just one of these pipes, usually I'd be thinking about creating a new material. So that's a workflow issue. So what we've got here in this project is material property blocks. What that lets me do is change the properties on a material without having to create an entirely new material. I get the benefits of batching, so I still get great performance, and it's also a workflow improvement. So these are the sort of tools you can find within this project, the sort of tips and techniques that are going to change how the workflow for your project that you're working on. Okay, thanks, Ife. So I really encourage you to download our latest beta, 2018.3, and grab this project and take the next step in your learning journey. Thanks very much.
Hello everybody, thanks very much for having me today. So earlier this year, we opened up the black box of rendering within Unity after listening to your feedback. And we introduced a new rendering architecture, which is called the scriptable render pipeline. Now this is a C# API for you to create your own custom graphics rendering pipelines. And with that, we created 2 template pipelines for you to either customize or to use in your productions. And this was released in 2018.1. First of all, there was the lightweight pipeline, lightweight RP, which is a lean, optimized, and scalable rendering pipeline for a whole host of Unity platforms. Then we have HDRP, high definition render pipeline, and this is a high fidelity pipeline for high-end PC and console. And on this foundation, on the script render pipeline, we've created a lot of tools. So for artists and designers, we released ShaderGraph, which is a node-based shader material editor. And now we're going one step further and introducing the visual effect graph. Now this is a next generation tool, which gives you more power to create amazing visuals. Similar to ShaderGraph in terms of it's node-based by design for artists and designers, but it's also programmable and extendable for programmers to fit into your pipeline. So each effect is its self-contained asset, very similar to ShaderGraph. And this means that you can share it among many of your projects or also on the asset store as well. And it's tailored for next generation platforms using compute. Now, if we compare this to the current particle system, which we all know and love already, right? There's a primary distinction between the two, and it's all down to the hardware on which they run. The particle system right now is simulated on the CPU, whereas a lot of the calculations of the visual effect graph are computed on the GPU, which means that compared to thousands of particles that we can have on the particle system, we can have millions with the visual effect graph. So the limitations we once had with a lot of our effects are now gone, and we've made it easier for anybody and everybody to be able to create something magical. So I want to jump into the editor and take a deeper look. So here we have a spaceship demo, a visual effects demo made by our graphics team. And this gives you an insight of what is achievable with the visual effect graph. So we'll jump into this real-time type game. It's running on the PC underneath here. And first thing we can see is things like the smoke and the sparks. And this is fairly simple. This is something we could probably do in the particle system as is. But the benefit of the visual effect graph and the rendering of millions of particles means that we could scale these particles and these effects way bigger. But let me take you to something more interesting. So here we can see lots of different effects happening at the same time. We can see the beams coming down from the camera. We can see all of these quads and particles rendering the background and the text animating at the same time. What's great about the visual effect graph? It hooks into all of the existing Unity features. So for this case, we're using the timeline sequencing tool to sequence what's happening and turn different visual effects on and off and animate the exposed parameters. So this is a much more interesting effect with millions of particles, multiple visual effects happening all at the same time. This is something that probably wasn't achievable with the particle system before, or you'd have to cache a lot of your particles, meaning that you can't dynamically manipulate them through time, like we're doing here. But I actually want to show you how this works in the editor. So here's the effect in the editor, and here's the visual effect graph, and this is this whole effect in one. But let's just break this down so it doesn't look too complicated. The very first time I saw this, I was thinking, whoa, that is so huge. But once we understand what's actually happening, it's easier to understand. One thing you may have noticed straight away is that we're not actually in play mode or compiled in the editor. And it means everything that we create in the visual effect graph, we can see in the scene view, like so. Now, the visual effect graph is comprised of 4 main blocks that we called, and they're here. We have spawn, initialize, update, and output, the rendering. So spawn, basically exactly as the word implies, it spawns and gets our particles ready to be rendered. So here we're saying we just want a single burst. We want to render all of our particles at once in one single burst. And we're using a point cache asset, which we could just make in something like Houdini or 3ds Max. And the point count is taken 65,000 particles. So that's all of the particles we need for this demo. And obviously in this point cache, everything has a position. So in initialize, which is very similar to the start function when we're coding in C#, we're getting all of our particles ready to be rendered and initializing them once in our scene. So each block, such as initialize, is filled up with context blocks, and we can add in different blocks and search them as we wish. So say if I wanted to change set color or something like this for initialization, we can do that. And there's a library of hundreds of pre-made blocks already. So in initialize here, I'm setting the capacity again, getting everything ready and stored in memory. I'm setting the position on the map, which is taken from my point cache assets, and I'm setting the target position. And then we go through to the update block. So update, very similar to when we're coding again in C#, renders everything, every frame, and we can manipulate the points in the world throughout the update sequence. So here, we're getting the target position, we're setting the position on the map, taking it from a height map, we're setting the color via time, and then we're also listening for certain trigger events, which I'll show you soon. Finally, we actually want to render our particles. This is using a lit quad output. So as we can see, it's rendering all of the height map data and the beams all lit, but we could change this to be different things and render different things. So I can convert my output, and I can select things like cubes, decals, lines, lit quad like we've got right now, mesh outputs, or unlit quads, and many, many more. And again, this is also extendable to as you wish. So we're saying this is how we're going to render the objects. We're scaling color, adding position. We're also fixing the orientation. So we could say, this is the fixed orientation that we've selected, but do we want to make it look at the camera? Or do we want to turn it to face the velocity that's currently moving? Finally, setting the alpha and setting the size. What's great is that we can also render many different outputs at the same time. So we've taken our noodle here, that's what they're called, great word for it. So we're taking the whole effect from initialize, update, and spawn, and applying all of that, calculations to some different outputs as well. So we've got a lit quad here, and finally we've got another quad output here. And this final one is changing all of the beams coming down from the camera system. Now, let's start changing some stuff around. I want to take this attribute here, which is a texture 2D, and it's passing in a height map, which is changing all of these surfaces here. I want to select my Unity logo, which is just a generated height map, and we can see instantly, dynamically, the particles change going into the update method to match this height map. Pretty cool, right? The next thing is, like I explained before, is that everything that we do in the visual effect graph can be changed by other Unity systems, such as timeline. So I'll just hop onto my timeline here, and you can see that I've hooked up my visual effect graph, turning on and off different effects at once, and also manipulating exposed variables via the visual effect graph into timeline. So as I scroll along here, and let's turn on this effect, we can scroll through. It's the wrong one, this one, that's correct. And we can scroll through and see the different effects happening at once. So I'm turning off different effects, you can see here, and changing and manipulating the exposed variables and parameters going into the effect graph, as well as changing things such as the height of the planets, the point lights around the scene. So I'm doing everything in one sequence. Great for linear storytelling. Cool. So let's jump back here and change some more stuff. As I explained earlier on, in my update context block, I'm waiting for a trigger event. Now this trigger event is then going to enable another set of the visual effects graph asset, which is waiting for a CPU event with initialize, update, and a lit quad. So let's go back and see where this bool is. So this is currently a bool that's only exposed in the visual effect graph. I want to convert this to a parameter, and this will then be exposed in the blackboard. So if you've seen the shader graph, it's exactly the same. So this is my blackboard. So this is all of my variables that I want to change. And we can see I have my new bool here. And when I press exposed, that means it's now exposed in the hierarchy for people to access via timeline, via scripts, or for just to turn on via the inspector. So let's tick this and enable it. And we've now enabled a completely separate block of the visual effect graph. So it's going through here. So let's close the blackboard. It's changing, it's going to the branch, and it's ticked this trigger event that it's been looking out for. We've linked it up to this, and now we can change anything and everything dynamically. So this effect here is initializing 2 million particles, setting a random lifetime. It's inheriting the color source. It's applying these vector fields, which again are assets created in something like Houdini, which is the Unity logo here, and going down to rendering. Now I want to add something extra. Maybe I want to set the color over lifetime. I want to set the size of my particles. I just want to change this base color. And let's pick a lovely magenta. Everyone loves magenta, right? When shaders are going wrong. And we can see, again, we're still not in play mode, but we can change the variables and see them happening in real time. And that's because we have auto-compile selected at the top. So I can turn that off and just compile as I wish, but I like to see my updates changing all the time, changing dynamically. So I'm not going to show you too much more, because I have a session on this later on, but I want to show you this one last effect, which one of the technical artists made in our Brighton office where I'm based. So when we go to this nucleus, the core of our ship, we can transition into this effect here. And this is rendering maybe 6 different effects at once. The core nucleus, the fire effect, the lightning, and changing stuff via timeline to give us this amazing effect with lots of post-processing applied. Again, none of this was possible with the particle system or any other effect tool we had previously. Cool. So, as I said, I have a session later on today, 3:15 in this room. So if you want to learn more about the visual effect graph, we'll be making some effects from scratch. And the visual effect graph tool is available right now on GitHub in our HDRP GitHub, and it'll be a package very, very soon. So thank you very much for having me, and have an awesome day.
Good morning, everyone. 2D, right? So with 2D, we always start with the foundation. A crucial addition that we've made to the Sprite Atlas feature is these new APIs that enable users to take control over when and how their Sprite Atlases are built. Right? So this is really important if you want to have a bit more customization in your pipeline. Also, for the sprite renderer, we added ability to sort by pivot, right? So this is for your sprites which maybe do not have a pivot in their center, and the typical use case here is characters, right? Which have a pivot very often in the bottom center. Okay, let's look at some world building. So it's been a good year for world building tools in Unity. 2D world building has been enhanced by really cool, really powerful additions to tile map. So we've introduced support for hexagonal tile maps. This includes both point and flat top variations. And with 2018.3, we're introducing isometric tile maps. So this adds support for a very common projection that's used in some of the most successful strategy and RPG games out there. We've also released a preview package of sprite shape. Right? So this is for the creation of more organic levels. If you're interested in this, I'll be doing a session on this in this room later on at 2 p.m. Okay, animation. Right? This is for the animators in the room. Our 2D animation preview package unlocks powerful 2D skeletal animation to enable artists to bring their sprites to life. Okay? So this includes rigging, sprite rigging workflows, as well as inverse kinematics. You can prepare your 2D characters for animation by adding a framework of bones, by painting weights, and previewing all of your deformations as you go. Right? And then you can bring that into the scene, and you've got your bones, and you're ready to go. You can start animating, setting up IK. Now, in the latest update, which is due really soon, you'll see support for working with characters made up of multiple sprites. And we've tightened up the iteration loop, so you can stay focused on rigging characters that animate beautifully. Okay, let's switch gears a little bit. Let's talk about graphics. Now, for the creators of pixel art games in the room, those of you who are making those really cool retro throwback style games, we haven't forgotten about you. This year we released the Pixel Perfect Camera. So this is a package that you can get that ensures that your pixel art remains crisp and clear at different resolutions on a wide range of devices and stable in motion. Now, this is a single component that makes all of the calculations that you need to scale the viewport with resolution changes, right? So you can deploy to all those different devices, and everything will just look crisp, look beautiful. And finally, I want to reveal a little sneak peek into an upcoming feature for graphics, and that's 2D lights and shadows. So this includes mobile-friendly shape-based lights, as well as 2D point and spotlights. And you can use these to make your sprites more dynamic, right? More exciting. So let's take a look at a video to see how this kind of looks together, right? How do these come together? So if we look at this example, you can see that we've added multiple shape lights to create light beams and circular lights around the moving characters here. We can see that this adds depth, variation, and mood to your 2D games. Finally, I'd like to take this opportunity to tell you about the Unity 2D Challenge. Okay, so you can visit the link here at connectunity.com/challenges/2D challenge. And we want to invite you to be part of this exciting community journey exploring the possibilities of the new 2D tools. So jump in there, make some really cool stuff with the new 2D tools, and show the world what you can do with 2D. Let's take a look at some cool 2D games now, as well as some of those features that we spoke about earlier in action. Thank you.
(2018) has been an exciting year so far. We've introduced many new features, both big and small. We've introduced machine learning, which let our developers tap into very complex artificial intelligence. And there will be a talk by Jeffrey from the machine learning team today, so if you want to find out more. And we've introduced scriptable render pipeline, where we've opened up the render pipeline black box. With it comes the lightweight render pipeline, a template which we provide based on the scriptable render pipeline. And of course, the HDRP, the high definition render pipeline, which targets high-end PC and console, allows you to create very high visual fidelity projects. And shader graph lets you create shaders in a very visual way, makes it friendly to the artists and designers to create and design shaders. So it's not just about the big features. We realize that often it is the small things that matters, and it is the small things that helps to make life easier and be more productive. So let's take a look at some of these smaller features that we've introduced.
1, 2, 3, listen.
So we are nearing the end of 2018. Unity 2018.3 will be out of beta very soon, with the long-term support edition following soon after. And Unity 2019.1 alpha is already available to try today. In 2019, you can be sure that we are working on even more exciting features. Here's a sneak peek at some of these features. So our community has been creating very impressive visuals with the HDRP, and very often VR developers will ask if they too can use HDRP for their VR projects. So now you can. We'll be adding VR support for HDRP in 2019. Project Tiny. Project Tiny will let developers make games that are performant, small, and compact. Apps or games made with Project Tiny can be embedded and played on the web browser, iOS or Android native apps. And sometimes when I meet developers, they will ask me, hey, can I do this with Unity, or can I do that with Unity? And usually I say yes. But sometimes I'll say yes, but you need to do some scripting. So in 2019, we're introducing visual scripting. So finally, scripting is finally available to non-coders too. And in 2019, with our partnership with Autodesk, we are integrating Shotgun with Unity. Shotgun is a review, production, and asset tracking toolset for VFX, animation, and games team of all sizes. Here's a video to show you a preview of what you can do with Shotgun and Unity. So Josh will be sharing more about our roadmap for 2019. If you're interested, he'll be giving a talk on that in this room. So to end off the keynote, we would like to show you a short video produced by Sparks Vietnam. So Sparks is a global studio who had worked on AAA game assets, VFX, film and TV shows like Star Wars Rebels. So when the team started on the project, almost none of the members had any experience with Unity. So we are very happy that they are able to achieve so much in such short amount of time. If you'd like to find out more, Fernando from Sparks is giving a talk on that today. Let's take a look at the video.
Hello, sir. Same as usual. Here you go. Forward, sir. See you tomorrow.